emitter current is equal to base current plus collector current. This is how the recombination take place in the base. If you see, a large number of electrons are shown in the emitter region, only a small number in the case of base region. Again, large number of them flow to the collector region. So, electron and holes, they recombine in the base region, only 5% constitute the base current, remaining 95% they cross over to the collector. Now, when you use this bipolar junction transistor, you have got three possibilities. ਸਾਡੇ ਕੋਲੇ ਤਿੰਨ ਟਰਮੀਨਲ ਹਨ, ਇੱਕ emitter ਹੈ, ਇੱਕ base ਹੈ, ਇੱਕ collector ਹੈ. So, I have been calling biasing. Biasing ਦਾ ਮਤਲਬ ਹੈ ਕਿ proper voltages ਜੋ ਤੁਸੀਂ transistor ਨੂੰ ਲਗਾਈਆਂ ਹਨ, ਜਿਵੇਂ ਮੈਂ ਕਹਿ ਰਿਹਾ emitter base junction ਹਮੇਸ਼ਾ forward bias, collector base junction ਹਮੇਸ਼ਾ reverse bias. So, biasing means applying proper voltages to the transistor so that you can achieve certain operating conditions. So, we have got three terminals, base, emitter and collector. इन्हां तिन्नां दे विचों तुसीं किसे नूं भी कॉमन कर सकते हो. बेस नूं कॉमन कर सकते हो, emitter नूं कॉमन कर सकते हो, ਜਾਂ ਤੁਸੀਂ collector ਨੂੰ common ਕਰ ਸਕਦੇ ਹੋ. ਜੇ ਅਸੀਂ ਟਰਾਂਜਿਸਟਰ ਨੂੰ ਐਜ਼ ਐਨ ਐਂਪਲੀਫਾਇਰ ਯੂਜ਼ ਕਰਦੇ ਹੋਏ ਬੇਸ common ਕਰਦੇ ਹਾਂ ਤਾਂ ਉਹ common base configuration ਕਹਿਲਾਉਂਦੀ ਹੈ. ਤਾਂ ਉਸ ਦੇ ਵਿੱਚ ਇਨਪੁਟਸ ਕੀ ਹੋ ਜਾਣਗੀਆਂ, emitter base voltage ਔਰ emitter current ਐਜ਼ ਇਨਪੁਟ ਹੋਏਗਾ. आउटपुट तो तुहाडे कोले कलैक्टर दे उत्ते करंट आएगा और कलैक्टर बेस वोल्टेज VCB नाल रिप्रैजेंट करते हाँ. जे असी एमिटर नूं कॉमन कर दईए then it is called common emitter configuration. Then at the input we have got base emitter voltage and base current. So input change होगी, देखिए it has become VBE and IB. IB means base current. Output is again collector current gives you the output and the voltage is VCE. If you make collector common, it is called common collector configuration. Inputs are base collector voltage BBC and base current, and outputs are base emitter collector voltage VEC and emitter current IE. This configuration is also called emitter follower because amplification in this configuration is just that of 1. Amplification 1 होया करती है, जो इनपुट है वही आउटपुट आएगी, जो emitter ਨੂੰ follow कर रहा है क्योंकि ये है, so it is called emitter follower. Now let us take up the common emitter characteristics first. Characteristics तो की भाव है, जो ग्राफ्स असी ड्रॉ करते हाँ वोल्टेजेस और करंट्स के विचाले एमिटर नूं कॉमन करके, कॉमन करने का मतलब अर्थ करके, बेस नूं इनपुट बना के ते कलैक्टर नूं आउटपुट बना के इन्हां नूं कॉमन एमिटर करैक्टरिस्टिक्स कहा जाता है. So you can define them that these are the graphs between voltage and currents with emitter at base as the input terminal and collector as the output terminal. This is an NPN transistor which shows you the common emitter configuration. If you see here, emitter has been made common. You can see it here again, emitter has been made common. क्योंकि NPN ट्रांजिस्टर है, VBE ਦਾ ਜਿਹੜਾ पॉजिटिव है टर्मिनल बैटरी ਦਾ, that is attached to the positive. Base is positive, P type, emitter is N type. So negative is connected to the emitter. This means this battery that has been attached, it makes the emitter base junction forward biased. If you see here, this is the collector terminal. This is an NPN transistor as I told you. Then collector is N type. So, the battery here, positive of the battery is connected to N, negative to the emitter. This means collector emitter region is reverse biased. This is the basic configuration that you can make in your laboratories. Base emitter forward bias, collector emitter reverse bias. Emitter has been common, that is why it is called common emitter. Emitter erred here. Base current is small, so you will use a micro emitter here. Collector current is large, you will use a millimeter here. There are three common emitter characteristics: input characteristic, output characteristics, transfer characteristics. Input characteristics तो मतलब इनपुट वोल्टेज और इनपुट ते जिहड़ा करंट हैगा, इनपुट ते किहड़ी वोल्टेज है जिहड़ी कि बेस ते एमीटर दे विचाले है, और इनपुट ते करंट किहड़ा होएगा, बेस करंट. So the graphs between base voltage and base current for different values of collector voltage, जो collector emitter ਦੇ ਵਿਚਾਲੇ voltage ਹੈ ਤੁਸੀਂ ਉਹਨਾਂ ਨੂੰ ਚੇਂਜ ਕਰ ਸਕਦੇ ਹੋ ਤੇ base emitter voltage ਔਰ base current ਦੇ ਵਿਚਾਲੇ ਜੋ graph ਹੋਏਗਾ that is called input characteristic. Input resistance, the ratio of small change in base voltage to small change in base current when you keep the collector voltage constant, it is what is called input resistance. Now, you keep the collector emitter voltage constant, you will get the graph like this. If you increase it, रखनी constant है, ਜਦੋਂ एक graph draw कर रहे हो ਤੁਸੀਂ collector emitter ਦੇ ਵਿਚਾਲੇ ਜੋ voltage ਹੈ ਇੱਕ value ਰੱਖ ਲਈ, let us say you keep it at 5 volts, then you keep on increasing base emitter voltage, keep on noting down the base current, then you draw this graph. Now, you keep the collector emitter voltage say 10 volt, then you will get another graph like this. So, this as you increase the collector emitter voltage, the graph shifts toward the right side. This is what is called input characteristic. You see, this is a graph between base emitter voltage and base current when you keep the collector emitter voltage constant. Output characteristics, output ਤੇ ਕੀ ਆਏਗਾ, output ਤੇ ਕਿਹੜੀ voltage ਲਾਈ ਹੈ ਜੋ ਅਸੀਂ collector ਤੇ emitter ਦੇ ਵਿਚਾਲੇ ਲਾਈਏ, ਤੇ output ਤੇ current ਕਿਹੜਾ ਆਇਆ, collector ਦੇ ਉੱਤੇ ਜੋ current ਆਇਆ. ਸੋ ਇਹਨਾਂ ਦੋਨਾਂ ਦੇ ਵਿਚਾਲੇ ਜੋ graph ਹੈ ਉਸ ਨੂੰ output characteristic ਕਿਹਾ ਜਾਂਦਾ ਹੈ. So a graph between collector voltage and collector current at different constant values of base current is what is called output characteristic. So ਤੁਸੀਂ ਕੀ ਕਰਨਾ ਹੈ ਕਿ base current ਨੂੰ constant ਰੱਖਣਾ ਹੈ. Let us say you keep the base current at 100 microampere, keep on increasing collector emitter voltage and keep on noting down the collector current, you will find a graph like this. If you increase the base current, you will get another graph. You increase it to 300 microampere, you get another graph. So, all these graphs, they are the graphs of output characteristic between collector emitter voltage and collector current. You can define output resistance here. So, output ਤੇ ਸਾਡੇ ਕੋਲੇ ਕੀ ਹੈ, collector emitter voltage ਹੈ और collector current है. So, the ratio of small change in collector voltage to small change in collector current keeping constant base current is what is called output resistance. This is another graph that shows you the output characteristic. This region that you see, where you see that there is no current, this is called saturation region, and these regions are called active region. This down below is what is called cutoff region. So, transistor has three regions of operation: active, saturation and cutoff. When you use the transistor in active region, then you will be using it as an amplifier. This is the most common use of the transistor, that you use it as an amplifier. If you use the transistor in this region, then this acts as a short circuit. You can use it in this region, cutoff region also. This is the open circuit. So, in these two reasons BJT is used as a switch by switching between the saturation and the cutoff regions. This is the output characteristic. This is again input character. These are the typical values, ideal graphs. Transfer characteristic. A graph between collector current and base current at different constant values of collector voltage is what is called transfer characteristic. Then what is AC current gain? A ratio of this collector current to the base current is what is called AC current gain. You can also call it as current transfer ratio. Now, this is actual common emitter output characteristic if you draw the characteristic in your laboratories. So, you can also use the transistor with a common base configuration. So, here base is common, base is earth. These are the different regions of operation: active, saturation and cutoff. And this is the common base characteristic that you will get. There is an active region here, there is a saturation region here. It is not the most common configuration, it is often helpful in understanding just the operation of the BJT. And if you make collector common, you will get common collector characteristic. This is basically equivalent to common emitter bias circuit, except instead of looking at IC as a function of BCE, you use IB. Now, let us compare different configurations: common base, common emitter, common collector. Input resistance in the case of common base is low, in the case of common emitter it is high, and if you use it as a common collector it is very high. Output resistance of common base is very high, common emitter is high, common collector की जो output resistance है that is low. Voltage gain of common base is low, voltage gain of common emitter is high, voltage gain of common collector is again very low. Very small leakage currents take place in the case of common base. Very large leakage currents take place in the case of common emitter and common collector. And where do we use these transistors in these configurations? When you use it as a common base, then we use it for high frequency application. अगर तुसी ऑडियो फ्रीक्वेंसी एम्पलीफायर के तौर पर यूज़ कर रहे हो तो असी कॉमन एमिटर यूज़ करते हाँ. Common collector is used for impedance matching of the two circuits. So, we conclude that common emitter circuit is the most efficient. Why? Because it gives you high current gain and high voltage and power gains. So, now we will be talking about how a transistor works as an amplifier. As I have explained you that if you make base common, it is common base, you make emitter common, it is common emitter, if you make collector common, it is common collector. So, again you can get three types of amplifier circuits. When you use the transistor, you can have common base amplifier, common emitter amplifier, or else common collector amplifier. In the case of common emitter is forward bias by using emitter biased battery, collector is reverse bias by collector biased battery. So, input resistance is small, output resistance is large, and we have been using these notations. Emitter current is written as IE, base current as IB, collector current as IC, again IE is equal to IB plus IC. This is how you can use it as a common base. You see, emitter current is shown as IE, it is NPN transistor. So, base is P type, emitter is N type. You use a common emitter voltage, a battery in between emitter and the base. So, this is the input signal shown here. Now, when positive half cycle comes here, when positive half cycle comes at the emitter, emitter is attached to negative of the battery, it makes emitter more positive. means it increases the forward biasing. If forward biasing increases, emitter current increases. And as I have shown you in the last slide, that emitter current is the sum of base current and collector current. So, if emitter current has increased, base current and collector current also increase. As current flows in the collector circuit, there is a potential drop that takes place across the load resistor. क्योंकि collector current बढ़ गया, IC बढ़ गया, so this thing which is being subtracted here for the voltage in between collector and the base, this thing decreases. Suppose first half cycle, as I told you, is positive. So, what has happened? Collector is connected to the positive pole. This increases in BCV, means it becomes more positive. That is, positive output has been increased. Collector has been connected to the positive. It has become more positive. When second half cycle of input is negative, it makes emitter more negative, means forward bias is increased. This increases and hence collector current increases. So, potential drop across load resistor increases and VCB, voltage across collector and the base, decreases, means it becomes less positive. So, more negative. So, this is how we can use a transistor as an amplifier. Thank you.